This is the one that I said we're going to do today. Now, to simplify this, please note that you have to apply all the exponential laws you have learned. When you have fractions, I would advise you that you need to deal with each the numerator separately and the denominator separately. Now you'll start with multiplication. I will start with multiplication. I will just multiply. I've got two bases in the numerator. So when I multiply them, I will just add the exponents, and I also have two bases in the denominator that are exactly the same. So I can simply represent each of those bases as one base and choose and the exponents. Now in the numerator, I'll still have a base of 3 raised to the exponent of 2m plus 3 plus 2 plus 3m minus 1. In the denominator, I'll have 3 to the exponent of m plus 4 plus 4m minus 2. Now that I have same bases, please note that the bases are the same, the exponents are the same, you are dividing. One option you can do here, you can take is simply to cross them out. You're allowed to cross them out only if they've got the same base and the exponents of those bases are the same, all right? Only if they've got the same base and the exponents of those bases are the same, you can cross them out, okay? Now, I will follow the simplest exponential rule, which says that you must represent it as a single base when you're dividing. You represent it as a single base, and then you take the numerator exponent, you minus the denominator exponent. In essence, all I'm doing is simply minus the denominator exponent, which is 5m plus 2. It will change and become negative. Okay, now please note that your exponents, your like terms will be 5m minus 5m, which is 0, and then you'll have 2 minus 2, which is 0. So you'll end up having 3 to the exponent of 0, and 3 to the exponent of 0 is just equal to 1. Everything to the exponent of 0 will be equal to 1, okay? Try this one. Let's see if you got it. Now you realize that here you will simply have to multiply the bases. You represent it as a single base. You add the exponents. In the numerator, you took the first exponent, which is 10n plus 9. You add a minus, a negative number. When you add a negative number, it will just stay negative. So you'll have to add minus 7n and minus 6. In the denominator, I took minus 8n plus 7, and I added 11 and minus 5, okay? Now, when you look at your like terms, you've got 10n minus 7n in the numerator. That'll give you 3n. In the denominator, you've got minus 8n plus 11n. That will give you 3n as well. In the numerator, I've got 9 minus 6. 9 minus 6 is 3. In the denominator, I've got 7 minus 5. 7 minus 5 is 2. So you end up having this. Now you will represent this as a single base, which is 5, and subtract the denominator exponent from the numerator exponent. And that will give you 5 to the exponent of 1. We normally don't write the exponent 1, so we'll just write it as 5. Try this one out quickly. Obviously, you have same basis. All you're going to do is simply represent it as a single base and then add the exponents. In the numerator, you'll have 100a plus 2001 plus 2a, 20a minus 2. In the denominator, you will simply have 60a plus 1001 plus 58a plus 1000. Okay, now look for like terms in the numerator. You've got 100a plus 20a. 100a plus 20a will give you 120. 60a plus 58a will give you 118a. And obviously, you just add the exponents. In the numerator, you've got 1999. In the denominator, you've got 2001. Then you will simply take the whole of the denominator exponent, minus it from the numerator exponent, and you'll end up having 2a minus 2. And that will be your final answer. From there, there's nothing you can do. Try this one quickly. All right, here you will simply start with the first one. You have to multiply the 2 that is inside the bracket. So you have to break the bracket by distributing the 2. So you will simply say 2 times x and 2 times 2. All right, that's the only thing you need to do. That's the first thing you need to do in the numerator. Once you have gotten rid of the bracket, now you can multiply the bases that are the same in the numerator by adding the exponents. Now you will write that as a single base in the numerator and just add the exponents. So that's why 2x plus 2x is 4 and 4 plus 3 is 7. Now that the bases are the same and you're dividing, you represent it as a single base and then you take the numerator exponent, the whole of the numerator exponent, you minus the denominator exponent. You'll realize that every time you minus the denominator exponent, if it was positive, immediately we move it up, it will be negative. If it was negative, when we move it up, it will be positive. So each of those terms in your exponent that is in the denominator, when it moves up, the sign will change. Similarly, when we move the denominator exponent to the numerator exponent to the denominator, its sign will change. So whenever you move exponent across division, its sign will change, right? And now that is why we've got 2. 2 is simply, we got it by taking 7, we subtracted 5 from it. So hence we have 11 squared. 11 squared will give us 121. Now we will be simplifying exponents by first prime factorizing. So sometimes we might need to prime factorize our factors, and that is solely because we cannot do anything. It will be difficult for us to do anything if we do not prime factorize. It will be difficult for us to simply solve if we cannot prime factorize. So we need to prime factorize the bases. Those are the steps we need to take. And then you will have to break the brackets by multiplying the exponents. Multiply same basis by keeping the base and adding the exponents. Divide same basis by keeping the base and subtracting the exponents. And then you write your answer as a positive exponent. All of those are the steps that you will need to follow to successfully simplify each of the following. Let's take, for instance, here, we've got 4 to the exponent of x times 2 cubed divided by 2 to the exponent of 2x plus 2. Now you need to prime factorize 4, okay, which is the base that is not prime factorized. Now look at what I'm going to do here. I am going to substitute with this 4. I'm going to substitute the prime factorized 4, which is 2 squared. So where there is 4, I will simply put in 2 squared. So it's still 2 squared to the exponent of x. Now I'll simply multiply the exponents. 2 times x will simply give me 2x. So in the numerator, I will end up having 2 to the exponent of x times 2 to the exponent of 3. Now I have 2 bases in the numerator. All I have to do now is to represent that as a single base and add the exponents. And then you simply continue doing what we did earlier on. You will simply take your denominator exponent and subtract it from the numerator exponent. You represent it as a single base, and then you will simply take your denominator exponent, subtract it from the numerator exponent. Remember, when it moves up, its sign will change. Like terms, we've got 2x minus 2x, that gives us 0, and 3 minus 2 will simply give us 1. So we end up with 2 to the exponent of 1, and that simply gives us 2. Let us look at this one. Try it quickly. Yes, you have to prime factorize 64, which will give you 2 to the exponent of 6, prime factorize 4, which will give you 2 squared, prime factorize 8, which will give you 2 cubed. All of those that are highlighted in red, we have to substitute the prime factorized form in this case, obviously, is the ones that we just did right now. And then you will simply have to distribute the exponents. I will actually explain this. You will simply take 6 times it by b, and then on the other bracket, you will take 2, you multiply it by b, and you take the same 2, you multiply it by minus 6, all right? In the denominator, you will simply take this 3 multiplied by b, right? Please don't forget that when you multiply binomial, both terms must be multiplied by the factor that you're multiplying by. So we'll end up having 2 to the exponent of 6b times 2 to the exponent of 2b minus 12. I did explain how we got that 12. It was 2 times minus 6. So that's how we got the negative 12. In the numerator, you've got 2 bases. In the denominator, you also have 2 bases. So what you need to do is to represent it as a single base and just add the exponents. So in the numerator, you'll have 6b plus 2b minus 12. In the denominator, you'll have 5b minus 13 plus 3b. I'm just going to highlight the like terms. Those are the like terms we need to add or subtract. In the numerator, 6b plus 2b will give me 8b. In the denominator, 5b plus 3b will give me 8b. So I will be left with 8b minus 12 in the numerator, and in the denominator, I'll be left with 8b minus 13. Note that when I subtract them, whenever I move my denominator exponents up, they change signs. So you realize that AB is now negative and 13 is now positive. It's because when I move them up, I simply change the signs. Why do I change the sign? Now think about it. I'm going to take the numerator exponent minus each of the denominator exponent. Do you agree that I will have 8b minus 12 minus 8b? But when I minus negative 13, it will give me a positive 13. Do you get it? So minus negative 13 will give me a positive 13 because minus a negative number changes that number to a positive, okay? Minus is a plus, okay? So that is why I've got that 13 then. And then you will just have to take note of like terms 8b minus 8b will give me 0. Minus 12 plus 13, however, will simply give me 1. Okay, change the sign of an exponent whenever you move it from the denominator to the numerator or vice versa. Just remember that. So in simplified form, that will be my solution. Try this one out quickly. So now here you will prime factorize 128, prime factorize 4, and prime factorize 8, okay? You simplify each to the simplest exponential form, and this is what you're gonna have. You do what we did previously, 7 times 8, 7a. 2 times a is 2a, 2 times 2 is 4. In the denominator, you will just have 9a. Now apply the exponential law of distribution, which is what we spoke about. You will simply multiply the exponents together. And this is what you'll get. In the numerator, you've got 7a plus 2a, which gives you 9a. In the denominator, you've got 3a plus 9a, which gives you 12a. Now all you're going to do is simply take your denominator exponent and multiply it from the numerator exponent. You will notice that you'll be left with minus 3a. Now, when you're left with minus 3a, I'm going to take the base, which is 3, with its exponent. Because the exponent is negative, I'm going to take the base 2 with its exponent 3a to the denominator and just put 1 in the numerator. And this is what I will have. But now I'm going to simply group 2 to the exponent of 3, and that will give me 8. So your answer will end up being 1 over 8 to the exponent of 8. Now this is a class work. Okay, attempt this. Give yourself 45 minutes, pause, and give yourself 45 minutes to finish that. Let's start with number one. You're going to add the numerator exponents because you're multiplying the bases that are the same, which is 2. That'll give you 3x plus, x plus 3 plus x. Like terms, which is x and x, you're going to add them up. Those will give you 2x. So you'll have 2x plus 3. In the denominator, you have x minus 1. Then you will take the whole of the denominator exponent minus it from the numerator exponent. So you will have 2x, 2 to the exponent of 2x plus 3 minus x plus 1, because that 1 is negative. When you minus it, it will turn to positive. This will give you 2 to the exponent of x plus 4. Okay, try this one out. I'm going to give you 5 minutes. All right, your time is up. That was actually more than enough time. Okay, let's see what you were supposed to have done here. You represent it as a single base in the numerator, you add the exponents, you do the same thing in the denominator. That's what you will get. At this step here, you have two options, and the easiest option, you've got same bases, same exponents, you cross them out. As long as between those bases in the numerator you don't have more than two bases, or between the bases that you're given, there's no plus or minus. You can just cross them out, only provided if there is only multiplication or division, okay, in between. Otherwise, you can't do anything. If there's division, that also complicates things. To make it easy, let's say when there is multiplication in between the bases and you realize that this base is the same as the base in the numerator and the exponents are the same, you can cross out. Okay, so in this case, I took the longer route by minusing the denominator exponent, which will give me 2 to the exponent of 0, which will simply give me 1. By crossing them out, your answer will simply be equal to 1. Okay, moving right along, let's try this one here. I'm not going to give you 5 minutes, that was too long. For this one, I will simply give you only 2 minutes, okay? All right, your time is up there. You were supposed to deal with the numerator and denominator separately. So in this case, you will have 3 to the exponent of x plus 2. In the denominator, you have 3 to the exponent of x minus 1 plus x. This is what you will get when you add the x's. And then you take the numerator exponent, you minus the denominator exponent, and you will simply get this. Simplifying this, you realize that 2x and 2x will give you 0 because you're minusing them, but 2 plus 1, those are like terms, same sign, you just add them and keep the sign, which is positive. You end up having 3 to the exponent of 3, which is 27. Let's move to the next one. Another 2 minutes. Let's go. Right, your time is up again there. You have to first prime factorize here. You will prime factorize 5 and prime factorize 125. 25 prime factorize will be 5 squared. 125 prime factorize will be 5 cubed. And then you distribute the exponent. So you will simply multiply this 2 with x, multiply the 2 with -1, and the denominator will take the 3 multiplied with x. Now, once you have done that, you can now, unfortunately, I haven't done anything in the denominator, but I'm simply going to represent the numerator as a single base and add the exponents. And then do the same thing in the denominator. Then minus the whole of the denominator exponent from the numerator exponent. 3x and 3x will simply give you 0. So I'll be left with 5 to the exponent of -3. The 5 and 3 exponent and the base, but the thing is the exponent is negative. You will take the base and the exponent to the denominator. Okay, you take the base and the exponent to the denominator and you divide that, you put the numerator as 1. All right. Now what you have in the denominator, that 5 cubed will give you 125. So it will be 1 over 125. Try this one out. All right. The time is up there. Prime factorize 4, 8, and 32. All of them, you need to prime factorize them. Distribute the exponents. 2 times x, 2 times minus 1. 3 times x, 3 times 1. 5 times x, 5 times 1. You will end up having this. In the numerator, you've got two bases that are the same, and you multiplying them, write them as a single base and add the exponent. 2x plus 3x will give you 5, minus 2 plus 3 will give you 1. I will simply write this as a single base and take the whole of the denominator exponent, minus it from the numerator exponent. You will be left with 2 to the exponent of minus 4. The base of 2 and the exponent of 4 will go to the denominator, and the numerator will be equal to 1. And 2 to the exponent of 4 is 16, so your final solution here will be 1 over 16. Try number 6. All right, for this one, you have to prime factorize 49. And then multiply out the bracket. So you will multiply 2 with x, that will be 2x, multiply 2 by 2, that will give you 4. In the numerator, the bases are the same. Write it as a single base, add the exponents. I've also highlighted like terms there, which is x and 2x. So you will add those. That will give you 3x plus 2. How did I get the plus 2? It's because of minus 2 plus 4. It will give you plus 2. Then you will take the denominator exponent, minus it from the numerator exponent. 3x minus 3x, that gives you 0. 2 minus 2 also gives you 0. To avoid that step, as I've said previously, you could have just crossed out 7 to the exponent of 3x with 7 to the exponent of 3x plus 2. Okay, 7 to the exponent of 3x plus 2 with 7 to the exponent of 3x plus 2. Because the bases and the exponents are the same, you can just cross them out, they will give you 1. Okay. Still not done. For these two, please do them at the same time. I'll give you 4 minutes. time is up here. For this one here, the first one here, all you were supposed to have done is just to cross them out. Okay, you realize that the bases are the same, the exponents are the same, so don't even stress yourself by prime factorizing. Just cross out. Cross out 27 to the exponent of x plus 2 with 27 to the exponent of x plus 2. Cross out 9 to the exponent of x minus 1 with 9 to the exponent of x minus 1. And then you will get 1. The main reason you've got so much time was for you to prime factorize this one, because this one has a lot of work in it. You first prime factorize 727, you prime factorize 27 in the numerator, and then you start multiplying out. 6 times x will be 6x, 6 times 2 will be 12, 3 times minus 2x will simply be minus 6x, 3 times 8 will simply be it's 8, 16, 24, it will be 24, right? And now once you have done that, you can simply take the bases and simply write it as a single base and add the exponents, right? You do that both in the numerator and the denominator. All right. Once you've done that, simplify by adding like terms. You'll end up having 3 to the exponent of 36 in the numerator, 3 to the exponent of 18 in the denominator. And then you're going to take 36 minus 18, and 36 minus 18 is simply 18. So you'll have 3 to the exponent of 18. It's your choice if you want to expand that, okay? You can expand it if you want to. It is absolutely your choice, okay? Try these ones. Okay, for this one, we'll get 2 minutes. All right, time's up. Prime factorize 27, prime factorize 9, prime factorize 81. You will get that. Same basis at the exponents. Like terms, add or subtract like terms. and then take the denominator exponent, minus it from the numerator exponent. So we have 3 to the exponent of minus 11. So you're going to take 3 and minus and 11 to the denominator and put 1 as a numerator, which will give you 1 over 17,000 and something, 177,147. Okay, that's your answer. All right, try this one quickly. For this one here, there's a trick. So I will give you 4 minutes. All right, your time is up there. Here's the thing here. you needed to prime factorize 36. And you couldn't prime factorize 36 by writing it as 6 to the exponent of something. And the problem is that we don't have a base of 6. Instead, we have a base of 3 and 2, which are the ones that we cannot change. All right. So you need to look at the bases that you cannot change and change the bases that you can change to the ones that you cannot change. All right. So all I'm going to do here, it's simply, okay, let me just do this. It's simply to prime factorize each of those. Now, let's see how I'm going to prime factorize all of that. All right. So in your calculator, you're going to press 36 and then equal sign. Then go to Shift and press Fact. It'll give you that. Okay, so 36, you're going to write, instead of 36, you're going to put inside the brackets 2 squared times 3 squared. And all of that is to the exponent of x minus 2. Please note that 2 squared plus 3x is still 36. So this 36 is raised to the exponent of x minus 2. So that is why I'm taking 2x, 2 squared times 3 squared. I'm still raising them to the same exponent of x minus 2. Okay. I don't need to prime factorize 3. I don't need to prime factorize 2. However, I need to prime factorize 12. So 12, 5, then you press Shift, then you press Fact. It gives you 2 squared times 3. So you put that in brackets. 2 squared times 3 raised to the exponent of 2x minus 3. We good. Great. 8 is easy to prime factorize. It'll just give you 8 cubed, right? Okay. Moving right along. This is what I've got. Now, we did this. Please check out, I think it was the first video where we distribute the exponents. I did specify in that video that all the exponents that are inside the bracket must be multiplied by the outside exponent, all of them. How many exponents do we have inside this first bracket here? How many exponents do we have there? There's 2 of them. It is 2 and 2. So each of those exponents will be multiplied by x minus 2. So you're going to take this and you're going to have 2 to the exponent of 2, and then you're going to multiply it by x minus 2. Then you're going to have times 3 to the exponent of 2, and then you're going to multiply this 2 by x and by that minus 2. Then you're going to do the same thing in the denominator. Now in the denominator, please don't be fooled by the fact that 3 doesn't have an exponent. The fact that 3, the exponent of 3 is not written, you must know by now it is equal to 1. Okay, so you will simply multiply all those exponents as well by the outside exponent, and this is what you will have. Okay, so all I did was simply to take the 2 and I multiplied it by the outside exponent. So this 2, as I've said, you multiplied by the outside exponent, which is x minus 2, and the exponent of 3, which is 2, you multiplied by the same exponent, which is x minus 2. In the denominator, you do the same thing. It will be 2 to the exponent. So the exponent of 2 will be multiplied by 2x minus 3. The exponent of 3, which is 1, will be multiplied by 2x minus 3. That is why it's just 2x minus 3. Anything you multiply by 1 will be itself. Okay, u times 1 is still u. You don't change. All right. Once you've done this, we're gonna apply the distributive property. You multiply the 2 with x, multiply the 2 with minus 2, and this is what you will get for each of those. Now you identify the bases that are the same. You write them as a single base, and then you add the exponents. The basis of 2 here, let me just choose a different color. The basis of 2 will be, well, this is the base of 2. That is the base of 2. Please note that there are people that normally ask me, but the other 2 is at the beginning and the other one is at the end. How come you're multiplying? Guys, it doesn't matter. You can simply, we call them I forgot the word now. It makes no difference whether you started by multiplying the last numbers or the middle numbers. Multiplication is multiplication. You can simply move them around. Okay, you can simply move them around. So all you're going to do now, you can move 2 close to 2 to multiply them. But the fact that the other one is at the end, it doesn't take away the fact that they're both multiplied. Okay, normally call it commutative property. Okay, that's the word that I was looking for. Commutative property. It doesn't matter. Guys, 3 times 2 is 6. Okay, let's say 3 times 2 is 6. 2 times 3. Does it matter the arrangement? Do I get a different number? Do I get different product? The answer is no, I don't get the different product. So you can move them around, but you will not get a different answer. So that is why I can simply multiply 2 with 2. As long as the bases are the same, I will simply add the exponents, okay? And then you're going to do the same thing in the denominator. So 3 will be multiplied with 3. Let me just highlight the bases that are the same that you're going to write as a single base and add their respective exponents, okay? So this one here will be multiplied with that. In the denominator, we've got this one here. We choose a different color. And choose this. So this here will be multiplied with that 3. There's no other base of 3 in the denominator, so that one I will not worry about it. So all of those that are highlighted, I'm gonna the orange ones, I'm gonna put it as a single base and add the respective exponents. So it will be 2x minus 4 plus 5x. The 3 will be 3, and I'm gonna have 2x minus 4 plus 1. Note that the other 3, since the exponent is not written, it means that the exponent of the 3 is equal to 1. Do the same thing in the denominator. The bases of 2 are multiplied, you write it as a single base, and then you add the respective exponents. The first 2 had an exponent of 4x minus 6. You're going to add it to the exponent of the second 2, which is 3x plus 3. And that's what you're going to have when you simplified everything. Please note that the 3's, you can cross them out because it's a base of 3 with the same exponent in the numerator and denominator. And between the bases, there's only multiplication. So you're allowed to cross them out. But when it comes to the 2's, all I'm going to do is simply take the numerator exponent minus the denominator exponent. Okay, something is wrong there. That this is what I will have. Note that the 3, which is the exponent of 2 in the denominator, okay? Remember what I've done here. All I did was just to cross these ones out, okay? But this 3 here, when I move it up, it will be positive. The 7, because it's positive, when I move it up, it will be negative. So you'll have 7 minus 7, which is 0, minus 4 plus 3, that will give you negative 1. So I'll end up having 2, so the exponent of negative 1, the exponent 1 and 2, which is the base, take them to the denominator, and that will give me 1 over 2. You good? Okay, fortunately you didn't see the answer there. Please try this one, right? Because it's also tricky, I am going to give you 4 minutes. All right. Yeah, you needed to prime factorize 12. What did you get when you prime factorized 12? You got 2 squared times 3, so you put that in brackets. Then you prime factorize 9, you prime factorize 4, you prime factorize 27. All of those, you put them in brackets. Then you multiply your exponents. This is what you will get when you multiply your exponents. In the numerator, highlight the like terms. As you multiply them, add their respective exponents. And this is what you will get when you add their respective exponents. Simplify the exponents. That's what you will get. Now separate the bases. For each base, you will take the numerator, you write it as a single base, you take the numerator exponent of that base, you minus the exponent of the denominator base. So basically it's the same base, which is 2. The exponent of 2 in the numerator is 2x. You minus the denominator exponent of 2 in the denominator, which is 2x minus 2. Please note that when you minus a negative number, it will be positive. Okay, so that is why here you're going to have 2x minus 2x plus 2 for a base of 2. And for a base of 3, you'll have 3 to the exponent of 3x plus 2 minus 3. Please note that for the first base, which is 2, 2 minus 2 is 0, which leaves you with 2 squared. For the base of 3, 3x minus 3x is 0, which leaves you with 3 squared. Please note that the two bases are still multiplied. So you will have 2 squared multiplied by 3 squared. 2 squared though is 4, 3 squared is 9. So it's like you're multiplying. Actually, it's you multiplying 4 and 9. And 4 times 9 will give you 36. We good. All right. Try this one quickly. I will simply give you how many minutes with respect to this one. Give you 5. Now I'll give you 4. Your time is up. Prime factorize 8, prime factorize 12, prime factorize 16. This is what you will get. Then multiply your exponents, and this is what you will get. Highlight same bases and add the exponents of those bases that you multiply. Then take the numerator exponent of each base minus the denominator exponent of each base. And that's what you will get. You'll end up having 2 to the exponent of 14 times 3 to the exponent of -1. Just to explain that, you're going to take 3 and 1 to the denominator, meaning that in the numerator, you'll be left with 2 to the exponent of 14. Because that base has a positive exponent, it will be in the numerator. 3 and 1 will simply slide into the denominator. So 2 to the exponent of 14 will give you 16,384. Try this one out. Same time, which is 4 minutes. All right, your time is up. So let's see what you're going to do here. You will prime factorize 576. What did you get? Did you get that? Prime factorize 576 and 24. Please remember, each exponent inside the bracket must be multiplied by the outside exponent. So 6, which is the exponent of 2, must be multiplied by n plus 2. 2, which is the exponent of 3, must be multiplied by n plus 2. In the denominator, 3, which is the exponent of 2, must be multiplied by 2n minus 1. And 1, which is the exponent of 3, must be multiplied by 2n minus 1. This is what you will get. In the numerator and denominator, highlight bases that are the same that you're multiplying, because when you multiply the bases that are the same, you need to add the respective exponent. In the numerator, it looks like it's only 2, so you will add that's 3n minus 12 with 3. In the denominator, it still looks like it's only 2, so you will simply take the 2 in the denominator and write it as a single base and add n with 6n minus 3. This is what you will end up getting. Simplified, it will give you that. Each base, you write it as a single base, and then you take the numerator of that base, the exponent of the numerator of the same base minus the exponent of the denominator of the same base. So I will take 6n plus 15 minus 6n plus 3, because when I minus negative 3, it will end up being positive, okay? And that will give me this. And simplifying that will give me this. You're multiplying the 2, it will end up giving you 8,388,608. This is how far they can ask exponents from grade 9 up to grade 11. The only thing that I'm missing here is where we simplify exponents that are added or subtracted. I will put that section under factorization, and the equations under that, I'll also put it under equations. Okay, so look out for factorization and also look out for equations, because I'm going to include certain sections that I left out in the exponent section under those sections, right? And what I can say is practice makes perfect, okay? Rewind if you need to when you don't understand the concept. Rewind, do it. Try to do things on your own first before checking out solutions, okay? And if you have any questions, please leave them under the comment section, or otherwise you can send me an email. Details are under the comment section. Subscribe and spread the word. Maths is just a wonderful subject. I hope I made it easy for you. Hozong.